Yeah, welcome to William's Guide to Mathematics once again. We've been working on the theory of logarithm, and so far so good. We've been able to learn how to change logarithm to indices. We've also solved problems using the logarithm indices relationship. And I mentioned to you the last time that we have 9 laws of logarithm, but we focused on just 4 of them. In this class, I will remind you of the first 4 laws of logarithm. We state the last 5 laws of logarithm, and then we solve problems involving the 9 laws of logarithm. You don't need to bother too much about anything. These laws are very simple. They are what you can easily get. Not to worry, William's Guide to Mathematics will give you a clear understanding of the 9 laws of logarithm. Let's take a review of the last 4 within the previous lesson.
Law 5. Power of the number law. Log x raised to power n to base a equals n log x to base a. When a log is raised to a certain power, the power moves to the back to multiply the log itself. When a log is raised to a certain power, the power moves to the back to multiply the log itself. Take for example, log 125 to base 5. 125 is 5 times 5 times 5. So we can say log 5 raised to power 3, which is 125 having 5 in 3 places, and the base 5. From the law, the power 3 can go to the back of the log, so that we have 3 log 5 to base 5. Remember one of our laws, the second law, which says that the logarithm of the base and the number being equal will be equal to 1. The base a and the number a are equal. The logarithm will be equal to 1. Therefore, we have our result to be 3 multiplied by 1, because base 5 and number 5 are equal. We are applying this law. 3 times 1 equals 3. Law 6. Power of the base law. Log x to base a raised to power n equals 1 over n log x to base a. When the base has the power, the reciprocal of the base is deduced and moved back to multiply the logarithm itself. When the base has the power, the reciprocal of the base is deduced and moved to the back of the log itself. Take for example, we have log 2 to the base 2 raised to power 3. The 3 here is a power to the base. first thing we need to do is to get the reciprocal of 3, which is 1 over 3. The 1 over 3 moves to the back of the log, and we have the number 2 and the base 2 remaining. Remember our law, when we have the base and the number to be the same, the number a and the base are the same, we say the logarithm of such is equal to 1. Therefore we say that we have 1 over 3 times 1, which is equal to 1 over 3. Law 7, called the reciprocal law. And we have log x to base a, it can be equal to 1 over log a to base x. When the reciprocal of a logarithm is required, the base and the number interchange their position. When the reciprocal of a logarithm is required, the base and the number interchange their position. Look at this illustration here. This is the number x, this is the base a. Getting the reciprocal, which is 1 over, we need to interchange the base and the number. Here the base is a. A is now the number on this side. Here the number is x. X is now the base on this side. We interchange this because we have just taken the reciprocal, which is 1 over. Look at this example for a better understanding. If we have log 7 to base 49, that can be taken as 1 over log 49 to base 7. We have 1 over log 7 raised to power 2 to base 7. Remember one of our laws, that is law 5. The power can come to the back of the log, just like we have n as a power here, coming to the back of this log to give log n log x to base a. So that will mean that we have 1 over the 2 coming to the back of the log, and we have our log 7 to base 7. That leaves us with another law that talks about the base and the number being equal. So that is giving us 1 over 2 times, when the base and the number are equal, we have 1. So we have 1 over 2 as our result. Law 8, called the change of base law. Log x to base a can be equal to log x to base n divided by log a to base n. We can express one logarithm as a ratio of 2 logarithms by introducing a common base for the 2 logarithms. The number and base of the initial logarithm will be the number for the numerator and denominator of the 2 logarithms. Again, we can express one logarithm as a ratio of 2 logarithms by introducing a common base for the logarithm. The number and base of the initial logarithm will be the number of the numerator and denominator of the 2 logarithms. We are saying here that we can express this logarithm x to base a to give us 2 separate logarithms. We have x, which is the numerator, as the log for the first, and a, the denominator, as the log for the second. So x, the number, will be for the numerator, a, which is the base, will be for the denominator. They will now take a common base like we have in this case. Let's take a look at an example where we have log 14 to base 6. We can express the two to have a common base 10. So we have log 14 to base 10 divided by log 6 to base 10. We are using base 10 because base 10 is a natural base. We can pick from our table, our mathematical table, that log 14 is 1.1461. It is 1.1461 because the characteristics of 14 is 1. And we can also pick for log 6 from our table that it is 0.7782. Therefore, we can say that log 14 to base 10 is 1.1461 and log 6 to base 10 is 0.7782. That will give us 1.4728 on division. The last law, law 9, logarithm as a power. M raised to the power of log x to base m. We give x. We say when the logarithm of a number is the power and the base of the logarithm is to the base to which the logarithm itself is raised, the result is the number. Again, when the logarithm of a number is the power and the base of the logarithm is the base to which the logarithm itself is raised, the result is the number. For example, we have 5 raised to the power of log 2 to base 5. It's equal to 2. We are saying here that we have logarithm as a power. The logarithm itself is a power. Something is raising the power, is raising the log to be the power, and that thing is a base. Now when the base that is raising the log and the base of the log itself are equal, we can have our result to be the number. The base for the log is 5 and the base to which the log is raised is also 5. These two bases can cause this log to cancel and our result to be equal to 2.
Before we take a look at the examples for this lesson, let me tell you that we can have a case of logarithm with no base. Remember we said at the beginning of theory of logarithm that we are working with logarithm with any base. The base could be given. But we can have some problems with no base at all. Now, when a logarithm has no specific base, the logarithm function is to the natural base. And what is the natural base? That is base 10. So if you have a logarithm problem with no base, consider the base to be in base 10. If I have log x, that is log x to base 10. If I also have log 5, that is log 5 to base 10. In this example, these bases are not specified. Remember I told you that when we have no specific base, the logarithm is to the base 10, the natural base. So we can have our log 30 over 16 minus 2 log 5 over 9 plus log 400 over 243. I said they will all take base 10, the natural base. At this point, we are supposed to apply the law of addition and subtraction, but we can't because of these two. We need to take these two away from this place, and to do that, we apply law 5, which says that anytime we have a power on a number, the power will come to the back. At the same time, if the number is at the back, it can also go to the front as a power. So this will give us log 30 over 16 in base 10 minus the 2 going up here, we have log 5 over 9 raised to power 2 in base 10 plus log 400 over 243 in base 10. Remember to put in brackets. So we need to evaluate this. We repeat 30 over 16. The base is 10. We have log 5 raised to power 2 is 5 times 5, that is 25. 9 raised to power 2 is 9 times 9, that is 81. Still in base 10. Plus log 400 over 243 in base 10. Remember in our previous video, which is lesson 2, we said anytime we have addition, we multiply. And anytime we have subtraction, we divide. So this will leave us with one logarithm for everything. Then we have 30 over 16. The minus is division. I will divide the number 25 over 81. The addition is multiplication. I will multiply 400 over 243. I'll put a big bracket for all. Remember the base 10. So that we have log. In our elementary mathematics, we know that anytime we have division, we can change it to multiplication. So our 30 over 16 remains. This division can change to multiplication on one condition, that the denominator here will come up and the numerator will come down. So we have 81 over 25. This will remain 400 over 243 because it's multiplication, unlike here we have division and we need to swap. So I will maintain this 400 up, 243 down. I will need to close the bracket I started with here. Don't forget, we need to maintain our base 10. 25 here 1, 25 here is 16. 16 can cancel 16. 81 here 1, 81 here is 3. I have 3 going here 1, 3 here 10. So I'm left with log, what number is remaining? 10, 1, 1, that is 10. What about the denominator? We have 1 here, nothing. So that's 10 over 1, which is 10. So our base is 10. Remember the law 2 that says that anytime the base and the number are the same, the result is equal to 1. So this gives us log, that means log 10 to base 10 is equal to 1. I can therefore say that log 30 over 16 minus 2 log 5 over 9 plus log 400 over 243 is equal to 1. In this example, we have log 27 in base 3. The 27 is having a root, that is square root of 27. We have the square root of 9 in base 3, the log of the square root of 243 in base 3. Now, I can have that to be log 27 raised to power half, because square root is raised to the power of half. Base 3 plus 2 log 9 raised to power half. It also has a root, base 3 minus log 243 raised to power half in base 3. Remember the law, the fifth law, telling us that anytime we have a power, it can come to the back of the log. So I can bring this half to the back, bring this half to the back, and bring this half to the back. That leaves me with 1 over 2 log 27 to base 3. Plus, we have a 2 here before the half, that is 2 times half, the coming half, log 9 to base 3, minus half coming to the back also, half into log 243 to base 3. Now, like the previous example, I can decide to join them by addition for multiplication and subtraction for division. But you will realize that 3, I can express 27 as a power of 3. I can express 9 as a power of 3. I can express 243 as a power of 3. What I'm saying in essence is that 3 raised to power something will give me 27, will give me 9, and will give me 243. I can as well ignore that other method which I used for the first example and use a different method, which means that I will write this as 1 over 2. The question is, this 3, bringing it here, 3 raised to power what will give me 27? That is 3 raised to power 3. I will maintain my base, plus this cancel this, we have 1, so we have log, the same thing, 3 raised to power what will give me 9? That is 3 raised to power 2. I have my base 3, minus 1 over 2, 3 raised to power what will give me 243? That is 3 raised to power 5. I have my base 3 also. I will now bring the power to the back like I did in the case of this half. This 3 will come here, the 2 here, same thing for this 5. So that we have 3 times 1 over 2 log 3 to base 3 plus 2 coming to the back with the log 3 to base 3 minus 5 times 1 over 2 log 3 to base 3. 3 times 1 over 2 is 3 over 2. Log 3 to base 3, remember our second law, which says that the logarithm of the number and the base being equal will give us 1. That is, log 3 to base 3 is 1 because the base and the number, they are the same. So I can have this as 3 over 2. The whole of log 3 to base 3 is 1. The same thing applies here. The whole of log 3 to base 3 is 1. I will maintain my 2 and I will multiply it with the 1 gotten from log 3 to base 3. This is 5 over 2. We also have log 3 to base 3 to be 1. So this will leave us with 3 over 2 plus 2 minus 5 over 2. Let us take us to primary school mathematics. Do the LCM. The LCM of all this is 2. 2 divided by 2 is 1. 1 times 3 is 3. 2 divided by 1 is 2. 2 times 2 is 4. 2 divided by 2 is 1. 1 times 5 is 5. So we have 3 plus 5, that is 7. 7 minus 5 is 2. So we have 2 over 2, which is equal to 1. Therefore, we can say that log square root of 27 to base 3 plus 2 log square root of 9 to base 3 minus log square root of 243 to base 3 is equal to 1. Now we have log 16 and log 32. I can express 16 and 32 with a common prime number, which is 2. I can have log 16 to the 2 raised to power 4 over log 32, which is 2 raised to power 5. The 4 can come to the back of this. Remember the fifth law, the power will come to the back of the log. The same thing applies to the denominator. The 5 will come to the back of the log. So we have 4 log 2 over 5 log 2. Then the log 2 cancel each other. We have 4 over 5. I can do a second method. I can do a change of base. That is log 8. So that I will have log 16 over log 32. This 16 will be the number and this 32 will be the base. So it becomes log 16 to base 32. So that we have 16 is 2 raised to power 4 and 32 is 2 raised to power 5. Log 5, the power on the number can come to the back as a whole number, that is 4. But the power on the base will come as a reciprocal, that is log 6. The power of the base will come as a reciprocal. The power on the base is 5. So the reciprocal of 5 is 1 over 5. So this will be times 1 over 5. So that we have times log, we have the number 2 and the base. So this is 4 times 1 over 5. Log 2 to base 2 according to law 2 is 1 because the base and the number they are the same. So 4 times 1 times 1 is 4, and we have 5 as denominator, which is so far so good. We've been able to review the first 4 laws of logarithm, which is based on our previous lesson. We've also worked on 5 laws after the 4, the new 5 laws, and we've solved problem involving all these 9 laws. I have some practice questions for you on this logarithm. I would like you to practice these questions, apply those laws correctly, and you will get it very easy. This is a very simple topic. All you need to know is you need to master those laws. Remember law 1, law 2, law 3, 4, 5, 6, law 8 and law 9. Once you are able to get this, theory of logarithm is a very simple topic. The answers to the practice questions are there. You can use that to evaluate yourself and check how well you understand this topic. We have 2 more lessons on theory of logarithm. You will get to see the video very soon.